today we are starting Chapter 8. So today is 8.1, Inverse Variation. Before we get into inverse variation, though, I want to remind you that towards the beginning of the year we did what we called direct variation. Direct variation, always said in the form y equals k times x. Remember, we said that k was what we called our constant. We also know that a direct variation, when it had a graph, it had to cross through the origin. So inverse variation is similar to that. For an inverse variation, we have y equals k over x, where k is still our constant. Anytime we were trying to find k in a direct variation, we always said k was equal to y divided by x. To find k in our inverse variation, we say k is equal to x times y. So you're going to be multiplying them together. The one thing I want to remind you of when it comes to an inverse variation, we always said direct variation, as one increased, the other one increased, or as one decreased, the other decreased. With an inverse variation, they work opposite. So as one variable increases, the other decreases. All right, so let's talk about how to identify it from a graph. So identifying a variation from, let's go with a table, from a table. Start with that. In a table, if I have my x and y values, let's say we have x is 1 when y is 4, x is 2 when y is 2, and x is 4 when y is 1. To determine if it's an inverse variation, we're going to look for the k value. To find k, remember we said it's x times y. So we're going to start right here and see if they're all the same. We're going to say 1 times 4 equals 4. The next point, we're going to take 2 times 2 equals 4. And the last one we have is 4 times 1 equals 4. Since these are all equal to 4, that is our k value. So when we rewrite our equation, or our inverse equation, we're going to write it as y equals k, which is 4, over x. This is an inverse variation. If you recall, when we did a direct variation, we always took our y and divided by our x to see if they were all the same. All right, so here we are with example number 1 today. The first couple of problems you have in your homework, so 6 through 8, they're going to give you a table. And in the table, they want you to determine if the table is direct, inverse, or neither. And then write an equation. Of course, we got to write an equation. That's what algebra is all about. All right, so here we go with your first table. Let's say my x and my y. I have 1, 12, 2, 6, 3, 4, 4, 3. All right, we want to determine if this is an inverse, a direct, or neither. So let's start with our inverse. To do our inverse, remember that k is equal to x times y. So we have k equals 1 times 12, which equals 12. In this one, we have 2 times 6, which equals 12. 3 times 4 equals 12. And 4 times 3 equals 12. So this is indeed an inverse because all of our k's are the same throughout. And so our equation is going to be y equals 12 divided by x. How about this one? Let me give you this table. In this table, here's my x and my y. Say I have 110, 220, 330, 440. All right, so again, let's see if it's an inverse. Remember, k equals x times y. So this would be 1 times 10 equals 10. 2 times 20 equals 40. You can already see that our k does not match, so this cannot be an inverse. So let's try direct. Remember, direct was k equaled y divided by x. So here we have 10 divided by 1 equals 10. Here we have 20 divided by 2 equals 10. Let me move that up a little bit. Here we have 30 divided by 3 equals 10. Of course, you got to check the last one. 40 divided by 4 equals 10. Since now our k is also the same throughout, this is a direct variation. And our equation is y equals kx, or in this case, 10x. All right, let's talk about graphing an inverse variation. So for graphing, inverse variation, I want you to first recall, I already mentioned this once, a direct goes through the origin. All right, so for example, no matter how it is, it's going to go through the origin in a straight line, right? Always goes through the origin. For an inverse variation, the graph cannot touch either axis. Well, I know what you're thinking. How does that work? Well, it's going to look something like this. It's going to approach both of the axes, but can never, ever touch them. You actually have two pieces of this type of graph. All right? So this is an example of y equals k over x. If I happen to have y equals negative k over x, so maybe that k value is a negative, the only difference in its graphs is that instead of it being in the first and third quadrant, it's in the second and fourth quadrant. Again, it can't touch either axis. All right, so for example number 2, this is how it looks. And this will be your numbers 10 through 18 as you refer back to your notes. All right? So it's going to ask you to write a function and graph the inverse variation. And all they're going to tell you is that x equals 13. So let me fix that a little. Oops, sorry about that. X equals 13 and y equals 10. All right, so the first thing we have to do, I want you to find k. Because we can't write our inverse variation until we find k. Remember, k is equal to x times y. So in this case, k equals 13 times 10. Oops, that's not a k. Or equals 130. So then, step 2, I need you to write the function. which is y equals k over x. So in this case, y equals, the k is 130 over x. And then it's going to ask you to graph. So 3, sketch a graph. All right. And when we sketch our graph, since the k value is positive, that graph is going to fall in the first and third quadrants. And you're just going to put curves that are approaching both axes, but never, ever touching them. It's getting closer and closer to each one, but never touches it. Let's try one more, very, very similar. So let's say that x equals 4 when y equals 5. So first, 1, find k. So k equals 4 times 5, or 20. Step 2, write the function. So y equals 20 over x. Step 3, graph. So if I were to graph this, again, k is positive, so my graph is going to fall in the first and third quadrants. All right. I also want to talk about combined variation, which means we can actually put both a direct and an inverse together. You're going to have to write some of those today. So, for example, if it says something like z varies jointly, which means more than one thing is happening, with x and y. So the word varies means that we have to have that constant k. So I'm going to start off with z equals, we've got to have a k, and jointly with x and y, we're just going to put x times y. Let's try a different one. How about if I say that z varies jointly sorry about that, my phone went off. Let me try that again. Varies jointly with x and y, and inversely with w. Again, varies means I got to have that k. So I have z equals k. Jointly with x and y means I'm going to multiply by x times y. We've already discussed that inversely means that I get to divide by w. So in the next few problems I want to talk about, you're actually writing your own variation equation, and then we're going to solve for some missing content. So here's the steps I want you to think about. 1, you need to write the function, just like we did, right? Step 2, plug in given information to find k. 3, write function with k. And 4, solve for the unknown. All right, so we did these with direct variation. I want to show you how they're going to work if we have a jointly thing going on. So in example number 3, we're going to jump down to 26 through 28. All right, it says first, write a function. Then find z when x equals 3 and y equals 10. All right, now it's going to tell you this. Z varies directly with x and inversely with y when x equals 6, y equals 5, and z equals 4. All right, so step 1 says to write our function. So we've got to take this beginning information right here and write our function. So we have z. Varies means we have a k. Directly means we multiply by x. Inversely means we divide by y. That's step 1. Step 2 then wants you to take this given information right here and find k. All right, so we're going to plug in 6 for x, 5 for y, and 4 for z, and solve for k. 4 equals k times 6 divided by 5. All right, so I actually get 20, if I clear the fraction, equals 6k. Divide both sides by 6, and I get k equals 10/3. We're going to leave it in fraction form because if you use a decimal, you're going to have to round. All right, so now I take my 10/3, I go back to where I started right here, and it says find z when x is 3, y is 10. We're going to use our k. So we have z equals, our k is 10/3, our x is 6, and our y, our x is 3. I'll see if I got the right spot. And our y is 10. So 10/3 times 3 is 10, divided by 10 means that z equals 1. I think we should try another one. Let's do example number 4, same idea. Okay? All right, let's try this one. Let's say we have find z when x equals 4 and y equals 8. And then it tells you that z varies inversely with the product of x and y when x equals 2, y equals 4, and z equals 1/2. All right. So again, the first thing we have to do is use this line right here to write our equation. We have z equals, varies means k, inversely means we're going to divide by the product of x and y. All right, step 2, we're going to use this information in order to figure out k. So we have 1/2 equals k over 2 times 4, or 1/2 equals k over 8 We can clear the fraction or cross multiply, which would give us 2k equals 8. So k equals 4. Now let's go ahead and write our equation before we actually try and find z. Our equation is z equals, our k value we just said was 4, over x times y. So now we're going to go back up here. We want to find z when x equals 4 and y equals 8. So I have z equals 4 over 4 times 8. So z equals 4's will actually cancel. We get 1 over 8 or 1/8. And again, if you choose to plug it in your calculator, make sure you hit math enter enter. And if you're multiplying on the bottom, you got to make sure you put parentheses around the entire denominator. All right, let's move on to example number 5. Example number 5 is going to be your 29 through 32. It says, if values are a direct variation find the missing value. All right, again, if it's a direct variation, remember it's y equals k over x, or if we have our k equals y divided by x. I just said that totally wrong. Let's try that again. Scratch that. We're going to say it one more time. Okay. Make sure I say it correctly. A direct variation is y equals k times x, which means to find our k, we're going to take y and divide by x. Sorry about that. So if in this problem you're given, let's say 3, 7, and 8y, and they tell you it's a direct variation. In the first one, if I have an x and a y, I can actually set it up as k equals. So I have 7 over 3 equals. In this one, I'm going to set it up in the same proportion, right? Y over x, or y over 8. To solve for the unknown variable, we can simply cross multiply. Y times 3, or 3 times y, is 3y. 7 times 8 is 56. And then to solve for y, we're going to divide by 3. Y equals, and you can leave it as 56 over 3, because if you were to put it in decimal form, you're going to have to round it. Example number 6 uses an inverse. Same idea. Before we get into that, let's try this first. So example number 6. So this is 33 through 36. For each pair, is an inverse variation. First, I just want you to find the constant. So when I say the constant, that just means k. So in these few problems, it's going to say that they give you a pair, let's say 6, 3. To find the constant for an inverse variation, remember that k equals x times y. So in this case, we have k equals 6 times 3, or k equals 18. All you have to do. So it makes it a little tougher here in example number 7. Example 7, which is going to cover your 37 through 40. It says each is an inverse variation. Find the missing value. So if you recall, when we did direct variation, we set them up in their proportions, or how you found k for each one. So in this one, if I have 3, 7, and I have 8y, since it is an inverse, And to find k, we say it's x times y. That's how we're going to set each of these up. So in the first one, we have 3 times 7 is equal to, and in this one we can go 8 times y. So we actually get 21 equals 8y. Divide both sides by 8, and we get that our missing number is 21 over 8. And again, I would leave it in that form. It's always better to leave it in fraction form because it's more exact. Okay? The last 12 problems or so shouldn't be a problem. Now, in the middle of this assignment, there are some word problems. All right? You got to read through them and figure out how to find your k. I know you can do it. Our homework today is page 503, numbers 6 through 40, even. All right, and I will see you all tomorrow.